Please, could you start the recording? Thank you. So I'm passing my, yeah, thanks. So Greta, please.
Yeah, working on it. You can see my slides here. So typical slide for
Yes.
spectroscopy systems. Let's start with the Harpia light. So in addition to the bigger systems, Harpia transient absorption systems, we have new one, which is Harpia light. So what we have here, unibody box, and let's see what we can achieve with this spectrometer. So how it looks like, what we can do. So it's class 1 product. What it means, it can be put it in any lab. You don't need class 4 requirements and so on, or safety glasses and or whatsoever. You can put it in the you could put it in the office, but yeah, Harpia light weighs 100 kilos, so just keep that in mind. So what we have in Harpia light, we have probe polarization control, while in Harpia TA we had pump polarization control. We have plug and play installation. We hope that we won't need engineer for the installation. What we can think of is training for just how to we can. I think we will have remote training or on-house training if it is needed. It's easy to use. We have from femto to nanosecond temporal resolution. So what is inside the system? We have transient absorption module inside the box, air-cooled femtosecond laser, automated harmonic generator. So also we have spectrograph inside the box, and everything is inside it. We have motorized intensity control, motorized polarization control, and so on. Yeah, under the hood, just to imagine what is under the house, under outside housing. So we have, as I mentioned, transient absorption module, which is on top of CB5 laser and harmonic generator. We think that we don't need to say what laser is inside the spectrometer, but if someone asks it and are keen to know, so we can tell it, but don't show it at your presentations or whatsoever. We think it's not necessary because we are selling analytical instrument. We will have new dedicated software for control and analysis. So it will be Harpia Studio. We still are working on analysis part, but we think before selling systems, we will be ready with the whole software package. How the software looks like. So we have laser and harmonics control. We can choose which wavelength we will pump our sample. Also, we can control shutter. We also have beam overlap optimization. In this case, it's manual. You just pushing the buttons and we have the overlap. And yeah, also probe polarization control. We can choose parallel, perpendicular, magical angle. Also write your own custom angle to have the polarization, pump energy, energy density control. Also can check what is the fluence on the sample. On the sample area, also we will have automated probe power optimization, automated probe overlap optimization, which can be done by push of one button. Talking about specifications, so we will have two modes in here, transmission and reflection, without any modules like a time resolved fluorescence module, microscopy module. Here we will have only transient absorption in transmission and reflection. We will have quite narrow probe spectral range, but so from 460 up to 910 nanometers. As I mentioned before, pro-polarization control, it is linear. Pump wavelengths are from harmonic generator, second and third harmonics. Delay range now will be in Harpia Lite 7.5 nanoseconds. Temporal resolution is around 290 femtoseconds. If we have laser with a little bit better specs, so temporal resolution will be better. Laser repetition rate maximum will be 60 kilohertz, but we can pulse pick it and have 1 kilohertz or whatsoever. Maximum data acquisition rate will be similar to Harpia TA, 3.8 kilohertz. Dimensions are here. Comparison, simple comparison between Harpia Lite and Harpia TA. What we have here. So with Harpia Lite, we have analytical instrument, while with Harpia TA, we can still talk about more scientific system, wavelength when talking about wavelength control. So in Harpia Lite, we have fixed pump wavelengths, while with Harpia, we still have the tunability option, automation. So Harpia Lite will be fully automated, while with Harpia TA, we have semi-automated controls, customer access. So in Harpia Lite, it will be very limited. Only sample area can be reached by customers, while with Harpia Lite, everything can be changed, used or whatsoever. When talking about customization with the Harpia Lite, now we have only one module, and in future we will think of more options maybe, but now, yeah. And while with Harpia TA, we still have all the possibilities to make it more custom at some certain, of course. So when when fixed wavelengths are not enough, so we still have Harpia TA to have all the possibilities for the customer. Talking about competition or other providers. So basically for single box solutions, we can talk about from nano to millisecond systems, for instance, Magnitude, Edinburgh Instruments. Also, we can talk about TimeTech, and yeah, while for femtoseconds, we are the only ones. Applications. So nothing different from Harpia TA. We can talk about still transient absorption and reflection. So basically energy transfer, exciton energy transfer, photo reaction dynamics, and so on. We can talk about Harpia Lite. So these measurements were made with Harpia Lite. Everything now is on our website, so you can check there. Talking about directions with Harpia Lite, what we are thinking of. So maybe with one foot go to pharma, chemical biology, maybe all of these production, photovoltaics, solar cells, coordination complexes, coordination compounds, and so on. As for sales instructions, so for now, this year we will sell 2 systems at the end of the year. So you see the lead time, it's for now 9 months. If you have opportunities, please include Harpia Lite as product in the opportunity to see what capacity we might need for the production. It's really important for us to know how many are interested in Harpia Lite. Also, feedback is also important. If you have more feedback from clients, such as specs, sample area, sample holders, if they would need cryostats, sample stirrers, if they say that price is too low, if it's possible. If it's too high, all the feedback is important for us. As it is new for us for having analytical instrument. If you also have quotations from Edinburgh instruments, magnitude, and so on, please share with us. It would be really helpful to see where we are in this industry. Also, we have already on website our information, also already with on social media and so on. Computer is not included. Operating system for computer should be Windows. Connection is Ethernet. No installation is required. No optical table required. Yes, but it weighs 98 kilos. Yeah, mean of experiment durations around 15, 30 minutes. Hopefully, also every time it depends on the sample and so on. Demo is available. So if you see that you will need a demo system for next year, we should plan it in advance because the production slots are still all are taken. So we could plan. So contact me if you see a must or need of demo at your country or at your company. Talking about user personas, I won't go too deep of it. So we will send you presentation. So just what was on my mind, I just wrote it here. Here we have typically asked questions. So talking about IOPA, I think everyone have in mind if it will be possible to have tunability. We're thinking of this, but maybe it will be after 2 or 3 years. UV probe, not feasible now. We are thinking also about future upgrades. We will see how it's going. Also, if people are talking about more UV range, we can think of this range from 350 up to 500 nanometers. So contact me if you see that it would be beneficial for them to have this narrow probe spectrum. Can customer use laser beam for the other experiments? No, because we wanted to leave it as class 1 product. Spectrograph, no external spectrograph is needed. It is inside the spectrometer. SP laser, yes, if we will see demand, we can have another module with SP laser. Of course, price will increase and so on. Talking about cryostats, we will also see what is the demand for cryostats, and I think it will be easily upgradable in the future to have cryostat in HarpiaLite sample area. Next, same thing goes with sample stirrer and sample mover. Also can be, we think it will be upgradable in the future, maybe even next year. So what is the energy on the sample? So it's from 1.5 microjoules up to 3 microjoules. Probe beam diameter and pump beam diameter will be on the slides. So if you have any questions, I think we can go there.
So I can see. Hi, do you have questions for Greta?
Yes, I have a question for the beam overlap. So how it need to start work with overlap? You need to manually overlap it roughly, and then automatically optimize the overlap. by software?
Yeah, so those positions will be saved during the production of HarpyLite. For instance, when you're changing between one or another wavelength of pump, so the overlap slightly changes. So basically, it should be automated.
Okay, so no steering mirror by manually, right?
No.
Manual, I mean, it's just click the button manually, right?
Yeah. So with HarpyIT, we had optimized last pump mirror, so it will be quite the same with the HarpyLite.
Okay. And reflection model, how to switch it? Or it's
Yeah, it's not that automated. So there will be one handle where you have to push in one mirror, and that's about it.
And what was the request for the samples physically? I mean, is the sample need to be like a mirror, or if or need to put the sample in some degree to get reflection?
So, no, so that what we have sample holder in the middle. You should rotate the sample holder rotate it. So yes, you have to do two things.
Okay.
Just a question about availability. So in September, mid-September, we have a fair. So it's in Switzerland, and which is really oriented. It's in Basel, and it's really oriented to pharma and chemistry. So my question is a demo system there where we could have samples that we could on the booth make some demos? Is this possible or not?
I think we should discuss, because for this year our schedule is quite packed already. So I don't know if we could have a demo system in there.
And do you plan to have one or two dummy models or no?
Dummies we will have, yeah.
Okay, it's better to be able to have customer bringing samples and do some tests, but okay. All right, thank you.
Yes, yeah.
We have a question in the chat. Will the HarpyLite at Photonic West be a live demo or a dummy?
Yeah, it will be a live demo. If the flight will be successful, but we are bringing Kipro, so everything should be fine.
Any more questions? I guess no. So before we move to next presenter, Domas, I would like to, I'm kindly asking all of you to also be part of our marketing campaign. And this is our new product, so you're welcome to put it on your websites, in your social media. I'm not sure we have already the image in our power bank, but I will check with marketing. So if you need any help on how to promote this product, please write to marketing@lightcon.com and we will share all the information with you. And now we're moving next to our next presenter, Domas.
Yes, hello everybody. So I'm Domas, as already presented me. I'm product manager of Carbide and Paras lasers, and I will introduce you about new Carbide module. Just need my screen. Yeah. So what we have here, what we did, so we have a Carbide CB3 module, which covers output powers from 20 watt up to 120 watt, 120 watt, and the standard repetition rates is up to 1 or 2 megahertz.
Domas, sorry to interrupt.
Yes?
We are seeing your full screen, not the presentation mode. Just in case you have a private message coming in.
I hope not. In a minute. Let me. How do I? It. Now is it okay?
Perfect. That's better. Thank you.
Okay. Thank you very much. Yeah, so I was saying that this is standard CB3 carbide model. So on regular models we have frequencies up to 2 megahertz, and now we took 40-watt carbide module and ramped it up to 10 megahertz. So basically, physically it's the same laser as standard 40-watt. The dimensions, everything is the same. The difference is inside it, and some of the external stuff is different, but I will come up to on the next slides. So to introduce the main parameters of the laser. So we have, as I mentioned before, it's up to 40 watt of output power. The repetition rate can be selected from 200 kilohertz up to 10 megahertz, which also at 200 kilohertz we would have about 200 microjoules pulse energy, and the pulse duration is, as our standard, below 250 femtoseconds, and even with this 10 megahertz frequency, we remain at the same pulse energy stability, which is below of 0.5%. What is a bit different from the standard model is the pulse contrast. Here we have 1 to 100, so we have pre and post pulses with ratio up to 1 to 100. On our standard CB3 lasers, we have twice better this specification, but this is our initial specification, and during the building further more modules, more units, we are hoping to maybe improve this parameter. But for now, as we're looking to which is supposed to be in the main applications, this parameter shouldn't be an issue for those. What is maybe the key advantage, and also compared to the competitors, is that we have ability to control the pulse speaker up to 10 megahertz in any pulse speaker division and up to a single pulse. As usually in the market, what you see, it's about the pulse speaker controls up to 1, 2, mostly I saw 5 megahertz, and some 1 or 2 lasers, but basically, we can control it every single pulse up to 10 megahertz. What also worth mentioning, what is the different specification from our standard, is the pulse speaker leakage. So we have here up to 0.5% of the output power. So theoretically, the output power of the pulse speaker leakage will be up to 100 milliwatts. It's the worst case, of course. Typically, we get better performance, but it's different from our standard CB3 model. So also this have to be taken into account. And what is also a bit new compared to this other CB3 models carbides, that we add a wave plate plus polarizer optical attenuator inside it. We have it as an optional feature for other carbides, but for this we make it as a standard one. In the next slide, you will find out why is that. So going further, I will show you all the features and options which are typically we have on other models, and which are available or not on this one. So to begin with, that maybe most important one is the external pulse speaker control. So as I mentioned before, it is available to control every single pulse. About the fast energy control option. So this is what what is it? It's the fast attenuator basically, and with the fast attenuator you can control every single pulse in the full scale. But in this 10 megahertz model, it's working up to 2 or 3 megahertz. Yeah, up to 3 megahertz. And using at the higher frequencies, the calibration of the attenuation is becoming unpredictable. So it's not usable for the user. But to overcome this issue, we added the optical attenuator, which we use it as the attenuator instead of fast energy control, because fast energy control attenuator is basically standard for all the carbide CB3s. So in this case, we make it the other way around. We make it a optical attenuator as a standard, and fast energy control as a additional. It will always be equipped with a laser, but it will be disabled by a standard. Moving further, it's about the BIBurst. So BIBurst is available at this model, but there is a one kind of limitation about the gigahertz burst pulse. So with we don't have anymore the gigahertz. It's kind of megahertz because the distance between the pulses in gigahertz in P-burst is the 1.5 nanoseconds. So basically, it's not the 400 picoseconds as before. And due to this, the spacing and need for the gigahertz pulse is reduced to is lower than in standard model. So we have a maximum of 5 gigahertz burst pulse inside that. Yes. But basically, we would be able to have the standard 400 picosecond burst spacing, but in that case, we will not achieve 10 megahertz of maximum frequency, but up to 9 megahertz, because we need to make a standard oscillator, which is with a standard frequency of 65 megahertz. So I already mentioned that the integrated optical attenuator is a standard option. Also, like PP divider function is also available at the full range in any division of the frequency. As currently the SPPT mode is not available for this unit, but we have plans on testing it and validating if it will be available during this quarter. Currently, we do not have the results if it's will be available. So we need more testing. As for the nanosecond mode, yes, it's also available, but a bit limitations that this feature is available up to 2 megahertz. And higher frequencies is not available. Regarding the harmonics module, so the laser is as a standard CB3 model, so it's compatible. It's compatible with the harmonics modules. But what is the key thing here? But we do not have tested and released the harmonics specifically for the high frequencies. So the pump energies and frequencies which we are currently have, it remains the same. So currently we have the pump energies minimum is 10 microjoules or so. So it's not available for a 10 megahertz. We have plans for this next 2 quarters to test and qualify the harmonics. We assume that, of course, at the higher frequencies, we could expect a bit lower, I'm not sure if a bit, how much, I don't know, but lower lifetime at higher frequencies. Regarding efficiency, we expect to have standard efficiency for the second harmonic, but it's not clear about the UV yet. So, but yeah, the plan is to test it along further this year. Scientific interface module, maybe I need to remind you what is it. It's the basically additional module on the CB3 laser, which you can have such outputs like uncompressed output or oscillator input and output out of the laser. So this is compatible. All the features are available. Just now oscillator output is reduced to a maximum of 0.3 watt. As standard is 0.5 watt. Regarding the external oscillator, yes, this laser can be synchronized with the seeded by external oscillator, but the frequency should be about 65 megahertz. Wait a minute, maybe, no, it's not 65, sorry, it's 75 is standard. So, and the output power must be at least 3 watts. And in the next quarters, we foreseen to test it with a bit lower output power oscillator, but for now we need at least 3 watts. So, and this coming to the question, is it CEP capable? The answer is no, as for CEP stability, we need the oscillator, specific oscillator, which powers are hardly reaching 1 watt, usually lower. So it's not suitable to seed the 10 megahertz model. And as for Cronus 3Ps, yes, it's compatible with that, but the technical details and parameters are not yet tested and finalized. So this was the view of all features and options on the laser. What is a bit, maybe it's a bit more technical information here, but due to the wide range of frequencies, the different processes behavior start to occur inside the laser in the cavity. So the sum of the parameters starts drifting inside, like the pulse contrast, the pulse duration becoming not the one we calibrate on standard lasers. So what we need to do is a bit change the laser behavior, and we have introduced the different frequency ranges, different frequency ranges for the laser. So if you want to, then you are working on a certain point of the frequency, different laser parameters inside the laser is applied for the laser, different timings, different calibration, pulse calibration tables. So this is a new behavior for our lasers. This is applicable only for this 10 megahertz model. So, and to jump between those different frequency ranges, we need to apply different preset. So let's say here you can see that I made an example of 3 ranges between 200 kilohertz, 1 megahertz, and one from 1 to 5 megahertz, and one from 5 to 10 megahertz. So let's say you are working at 500 kilohertz, so certain pulse calibration and timings parameters are applied. And if you want to change the frequency to 3 megahertz, you need to apply the preset. In that way, laser will apply different timings and pulse calibration tables to be more optimal for that frequencies range. So, yeah, so basically that is the main difference in the laser firmware side and usage of the laser. And as I mentioned before, the dimension of the laser and everything is the same, only is inside, but expect of the external devices. So it's the power supply and the chiller. By standard for 40 watt carbide, we have a bit smaller power supply of maximum power of 600 watts. But here for this model, we need a bit more power to drive the laser, to drive this Pocal cells at that high of frequency. So we need more power. We are using the 80 watt carbide power supply, which can deliver 1 kilowatt of power. So this must be taken into account, and also as it uses more power, it exceeds more heat from the laser. So we need more powerful chiller to cool down that laser. So we also need not only the different power supply of the 80-watt carbide, but also the more powerful chiller. So this chiller is the same for 80-watt carbide. So it's SMC HRR chiller. You can see here the specifications, but they're available everywhere. So this basically exterior related difference with this laser. So the power supply doesn't become much bigger, but slightly. The chiller is a bit more, could be more an issue. You need to replace it, but it's not a big issue. As for the parameter information in our websites and catalogs, here's I just screenshot our parameters table. So here's the new model, how it looks in our all CB3 models, among all the CB3 models. So it's the pulse energy, the frequency is highlighted, and what is the difference as well? The standard attenuator is the wave plate attenuator, not the fast energy control, and the pulse peak reach. Maybe here we released the catalog maybe 1 month ago. So here the information we need to take a note about that the power supply and the chiller. According to the table, it should be as the 40-watt, but it's basically as the 80-watt. So if you're looking at the catalog, you need to pay attention that this must be corrected. But we updated this information already in the website and in our digital catalog. So about the applications, so there are a few key applications we are focusing at, which could be beneficial. It's the most of it's like microscopy and optogenetics, as it needs the higher frequencies. Also, so microscopy is the 2 or 3 photon imaging. Also, one of the key applications could be the data writing. This data writing would be more like industrial application if the customer does the technology, so that could be could be a successful place. But most of it is the scientific market, which for the microscopy, optogenetics, also Raman microscopy. So some information points about the sales lead times and etc. So this module just finished the development stage, and now it's moved to our introduction to production stage. What does it mean? It means that it does not manufactured yet by our standard production line. So the lead times is not our standard lead times, but they are specific according to the situation about how many units we have already in stock or prepared. So expected lead time is about 4 to 5 months, but it could be even shorter or maybe also longer due to in case there are less or more orders. So the exact lead time should be clarified after the request. Also, that not all the documentation and certification is done yet, but these stages, these processes are going to be done during this introduction to production stage. So it should be done during this 2025, but of course, most of the documentation and certification which is needed to deliver laser to the customer is planned to be done at early this year. But what I want to say that in some cases we need some time to prepare maybe the update user manual or so due to this model. Also, maybe worth mentioning that the specification could slightly change during this stage. As we produce more and more units, some of the parameters we could see from the practice that might be a bit different than we expected. But for now, we put it as a conservative parameters, so shouldn't change a lot. So currently we already have built 4 units, basically, which can be delivered in the first quarter this year. This is beginning from maybe February, from the March more or less. For the roadmap, what we foreseen for this laser, after we finished moving to production this model, we will check the feasibility of the higher power. We've seen the need of that, about at least 50 or 60 watt. But that means we need a bit different technical approach for this model. So we are planning to do it maybe sometime this year. After, depends how much process we need to fulfill for this model, 40 watt. So later on, we will try to check the higher power performance. As I mentioned before, we have plans of checking the harmonics and specifying and having the parameters for the highest frequencies. It's not only 10 megahertz, it's also, would say, anything above 1 megahertz or 2 in that case, because we did not explore this area yet, as we did not have the source for that. And one of the key success points here with this 10 megahertz laser is our OPAs. So we must have the OPA working at that kind of the frequency. So currently, it's also this project is under development, and with the current stage and the situation, it's planned to be kind of finished. The development should be finished by the end of this year. So that would be expected OPAs, but we expect to have some maybe news about OPA. For now, we have one standard model, 10 megahertz, 40 watt, 200 microjoules. And any other parameters, custom parameters, should be discussed with our sales team. If you see any more specific area, maybe some parameters are not necessary, or some features. So yeah, we can discuss it, and we'll have some mutual agreement on that. Yes, I think, yeah, so that's it about 40 watt 10 megahertz carbide model. So maybe you have any questions for me. If not, you can also think about the after the presentation. And as Natalia said, I will be in Photonic West next week, so you will be able, if you also there, you can catch me and ask questions face to face. But also you are open to ask here. Okay, Caio? No?
Yeah, I have a question for what kind of Raman spectroscopy would be benefit for the 10 megahertz from 10 megahertz carbide? It's like FSRS or CRAS or
the specific application, I couldn't say that for now. What is the specific application? Is basically what you have is the higher energy what you can apply to the material. So
okay, thank you.
I can look into for more special applications. Yeah, I can look into later and give you more details about that. Okay, it looks like no more questions. If so, as I said, you can just write here the text and we will reply later, or just email Natalia or catch me on Photonic West. Okay, Natalia, I think, is absent now, so I will say thank you everybody for participating in this webinar. I hope you found it. Ben, you want to say something?
No? Oh, no, sorry, no, I'm just turning my camera on and mic on. Just to say thank you.
Okay, so yeah, thanks again for participating. We hope that it was kind of useful for you, and we hope seeing you somebody in the show, or if not, so have a good evening, and thank you.
Yeah. Thanks, Thomas. Thanks, Greta.
Thank you.
Bye.
See you next week.
Bye.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.
Bye bye.
Goodbye.
Bye.
Bye bye. Thank you.
Bye.
Bye-bye. Thank you.
Bye all.
Kaip gali stabdyti?
Wow, stop.